Welcome back to Hansen Math tutorial videos. Today's installment regards monomials, multiplying, dividing, and raising to a power. If you're not sure what it means to be a monomial, you might want to refer back to the prior lesson where I went into great depth on negative powers and raising to zero and reciprocals and all that good stuff. So you can always refer back to the previous lesson on monomials, and if you're comfortable with that, we're going to go into some heavy-duty multiplying and dividing. Okay, so we're going to start off here with two monomials. We have 2x squared y, and we're multiplying by a second monomial, 3x to the fourth y cubed. Now, what happens when you multiply these together? I'm going to show this by doing what's called expanded form, so we're basically going to write it out in parts. Looking at the first monomial here, this guy, we have a 2, we have x squared, which means x times another x, and we have y to the first, which is just 1y. Now, all of that good stuff is being multiplied by this dude here, which is multiplying by a 3. X to the fourth is 4 multiplications of x. And then finally we have y to the third, which is 3 multiplications of y. Putting it all together, this is a multiplication problem, so you have to multiply the coefficients here. So we have a 2 times 3, which gives us a 6. And then we have to take a look at how many x's and y's we have. We have x times x times x times x times x times x. That's 6 repeated multiplications of x, so that becomes x to the 6 because there are 6 of them. And for the y's we have 1, 2, 3, 4. That's y to the fourth because it was repeatedly multiplying 4 times. Remember, exponents are repeated multiplication. The exponent tells you how many times you repeatedly multiplied. But even though it's multiplication, the way exponents work is because you're kind of counting how many repetitions of multiplying you have. Again, in the x you had 1, 2, 3, 4, 5, 6, so you're adding those 1, 2, 3, 4, 5, 6. And for the y's you had 1, 2, 3, 4. You're adding those and you get 4. So in essence, when multiplying monomials, you do multiply the plain constant numbers. But if you have the same variable, like working with just the x's or just the y's, in essence you end up adding the exponents. Okay? For the you try problems down here, if you want to hit pause and give them a go, feel free, make this video your own. And if you want to keep watching, we're going to go. We have y squared, which would be like 2 multiplications, times y squared another 2, times y squared another 2. So you have 6. Okay, 2 plus 2 plus 2 is y to the 6th. Okay, in the next one we have a monomial times another monomial. Remember, it is multiplying, so you multiply the constants. 4 times negative 2 is negative 8. Now, looking at the a variable, we have a to the second and a to the fourth. 2 and 4 adding gives you 6. Sorry for my power being pretty big there. And the c variable, we have 3 and 10. 3 plus 10 is 13. So your answer is negative 8 times a to the 6th times c to the 13th. And then finally here we have 6z times another z. So you have your 6, and z times z is z squared. Alright, moving on. What happens when you divide a monomial? Well, we're going to look at this a couple of ways, but first we're going to look at it in expanded form. If we have p to the 5th in the numerator and p to the 9th in the denominator, we're going to write it out expanded. P to the 5th is p times p times p times p times p. 5 multiplications. P to the 9th is 9 of those in the denominator. 3, 4, 5, 6, 7, 8, 9. Now, You've learned prior, or you should have, that when you're working with fractions, anything in the numerator divides with the same thing in the denominator. They become a whole. Like 3 out of 3 would be a whole. Well, p over p is one whole. So you have one whole, one whole, one whole, 1, 1. So you're left with 1 on the top, and in the bottom you're left with p times p times p times p, which is p to the 4th power. So one way of doing this is you can say, well, look, you little 5 on top, you're outweighed by the 9 on the bottom. So the 5 goes out, and 5 goes into 9 with 4 left over. So that's why you have 1 over p to the 4th. Now, another thing you can do is you can subtract the exponents. That was 5 take away 9. If you have p, because that was the variable base, and you have 5 take away 9, that's a 5, that brings you into the negatives by 4. Okay, so these are the same thing. This and this are the same. It's usually bad form to put negative powers in your answer, so this one would be preferable, but they are the same. 1 over p to the 4th or p to the negative 4th. Now, here's a special one here. Z to the 4th divided by z to the 4th. Okay, we've learned that anything divided by itself, like I just said, is one whole. So the answer here is one whole. Now, if you keep the base of z and subtract the powers, you had 4 on top minus 4 on the bottom. You'd have z to the 0 power. And as we talked about in the previous video lesson, anything to the 0 power is just one whole. Okay, so that's your fact of the day here. Any number raised to the 0 power is just 1. So to recap here, when you're multiplying monomials, when you have a variable and you're multiplying, you add the exponential powers, but when you're dividing, you divide any constants, and if you have the same variable, you subtract the exponential powers. Okay, so we're going to hit these you try ones here a couple of ways. If you'd like to hit pause and try them on your own, make it yours. If not, we're going to keep going. Okay, since this is division, we have a whole 6 and a whole 2. 6 divided by 2 is 3. And we have n to the 5th on top and n to the 2nd. The 5th outweighs the 2nd power, so this goes out. And 2 goes into 5 with 3 left over, so it's 3n to the 3rd. Now if you didn't like that, you also could have said 6 divided by 2 is 3, and you could subtract the powers since it's dividing. N to the 5th divided by n to the 2nd, you subtract, and 5 minus 2 is 3. So either way, you get 3n to the 3rd power. Over here we have 8y to the 8th divided by y to the 6th. Well, we have our x on top here, so we're going to have that. And then in the y dimension, you have 8 on top and 6 on the bottom as far as the power. So by rule, since it's division, we subtract 8 minus 6 is 2. There's your answer. If you wanted to hit that from a different perspective, you have your x, you have y to the 8th on top and y to the 6th on the bottom. 8 wins, so it stays on top because it's bigger. So this goes out and 6 goes into 8, leaving you with 2. So there you have it. Okay, 2 different perspectives with which to look at it. Finally, in the last example here, you have a 2 on top and a 10 on the bottom. That's like simplifying a fraction. So 2 goes into itself once, and 2 goes into 10 5. So far we have 1/5. Now you have x squared on top, x squared on the bottom. That cancels because anything over itself is one whole. And now you have y to the 6th and y to the 8th. 8 is bigger, so the bottom wins. How much bigger is it? Well, it's bigger by 2. That's the way I like to do this. Now, if you want to do it from the other approach, I'll say or, you could have your 1/5, and with these y's here, you could subtract 6 on top minus 8 on the bottom. 6 minus 8 is -2, but you're just going to have to take the reciprocal anyway. So you have your 1 on top you have your 5 on the bottom, and y to the negative 2 goes to the bottom as y to the second. Again, we covered that in the previous video. Now we're going to move on to some special power properties in algebra. This is when you have a monomial and the whole thing is raised to a power on the outside. So in our first example here we have 2x to the fourth. This fourth power only regards the x, but the whole thing, the whole monomial in parentheses, is being raised to the third power. So again, that third power means you're multiplying 3 times. What are you multiplying 3 times? What's inside the parentheses, namely 2x to the fourth times itself times itself. Now, learning what we already went through today, multiply the coefficients. 2 times 2 times 2 is 8. And when you have the same variable x, you keep it and you add the powers. 4, 4, and 4 is 12. So here you have 8x to the 12th. Okay, this is very important to try to keep together here. When you have a power raised to a power outside parentheses, you basically distribute or multiply the exponent to the variable powers inside. Okay? We will take a look at these. You can pause and try them on your own, or we can try them together. Okay, note you have a to the fourth, that's on the inside, 5 is on the outside. When you have this situation, you multiply. So now we have a, 4 on the inside, 5 on the outside, 4 times 5 is a to the 20th. Next example, you have to be a little bit more careful. You start with negative 5, which I'm going to rewrite here. Negative 5 is raised to the third. Okay, we'll take care of that in a minute. Now we have powers on the inside raised to a power on the outside. By rule, that's multiplying. So we have p. It was raised to the second, but that's being raised to the third. 2 times 3 is 6. And we have s to the fourth raised to the third, which becomes s to the 12th. Now, we're not quite done because I don't like the looks of here. It's not simplified. Negative 5 to the third power means negative 5 times itself, which is negative 125. Now that's simplified, and we rewrite our p to the 6th, s to the 12th. And last example here, we're raising this negative 2m over n to the fourth power. So that means that negative 2 is raised to the fourth power, m is raised to the fourth power, and on the denominator, n is raised to the fourth power. So to simplify this up a little bit, negative 2 to the fourth is negative 2 times negative 2, which is 4, times that again, which is 16, m to the fourth over n to the fourth. Okay, very good. Now, a little bit more working with negative exponents. If you remember from the previous lesson, the negative 1 power is the same as taking the reciprocal. So the reciprocal of 1 over 2 is 2 over 1, which is just 2. A negative exponent requires you to take the reciprocal of a number. It's nothing to do with a negative value, it's the reciprocal. So how I like to do this is the following. In the you try here, with a over 3 raised to the negative 2 power, the negative 2, the negative part of that just tells you to take the reciprocal. So instead of a over 3, now you're going to have 3 over a. But you still have to apply the second power. So doing that, you have 3 squared, which is 9, and in the denominator, a squared is a squared. So that looks like a 3, sorry, a squared. Okay. And in this dude here, you have a negative power again, which tells you to take a reciprocal. So now you have 6 on top and 3x squared in the denominator. And now that's being applied to the positive 2 power. So if you work on that, 6 squared is 36. And in the denominator, 3 squared is 9. And x squared squared, a power inside, a power outside, multiply. 2 times 2 is x to the fourth A little simplifying here. 36 over 9 is the same as 4, and in the bottom we still have our x to the 4th. That is your final answer. Grand finale time. Definitely want to hit pause and try this one on your own. Grab a sheet of paper. I'm going to work on it in a second, so this is your last chance to pause. If not, I'm going to work it through. Alright, so we have to apply everything on the inside to the third power. So our negative 4 is raised to the power of 3, and our x to the 2n is raised to the power of 3. Now this is power to a power. If you have power on the inside and one to the outside, you multiply. So that would be x to the 6n over, okay, again, power to a power, multiply. We have x raised to the 3n times 3 is 9n, and z squared raised to the third is z to the 6th. Now, we do have a little bit of simplifying here. Negative 4 to the third means negative 4 times negative 4 times negative 4, which is negative 64. We have an x to the 6n on the top and an x to the 9n on the bottom. This wins because it's bigger. So this goes away, the bottom wins, and 9 is 3 more than 6, so that's x to the 3n, and z to the 6th remains in the denominator. Final answer. How many of you got the finale? I hope you did. Okay, that ends this installment of Mr. Hansen Math videos. Hope you learned something more about multiplying and dividing monomials. Catch you next time.